That is the Kepler Space Telescope in a beautiful image they released, an artistic rendering to show that it found lots of exoplanets, or planets around other stars, which we call exoplanets. The yellow ones are representative of planets that Kepler has found. The blue ones were others since Kepler, and the dark blue were before Kepler. Vertical is how big, size relative to Earth, so one would be Earth-sized ones, 4 times, 10 times, and 20 times the size. You can see our planets you're familiar with on the right-hand side. And then across the x-axis is the orbital period. So Earth would be located at 365, we'd be about there. So notice we haven't quite yet found the exact Earth analog, but we're looking for them. Anyway, Kepler first has candidates. They find what looks like it could be a signal from a planet. And it finds them by, as the exoplanet passes in front of its star, it blocks out a little bit of the light. Well, here was a candidate number 1, that they thought the star was about 1.1 times the size of the Earth, about 10% bigger than the Earth, 10% bigger than our sun, and the dip would have needed to be caused by a planet about the size of Neptune. But all of a sudden they saw a secondary dip in the light. A Neptune-sized planet, as it passes behind the star, can't cause another dip. You need a very large-sized star that's reflecting light from the star that gives you a little bit extra, and then when it goes behind the star, you lose that extra little bit of light, creating a secondary dip. So the data didn't match up, and they said, this isn't a real planet. Let's toss it aside. So the very first candidate that Kepler ever had to be an exoplanet was set aside. They didn't think it was real. However, fast forward to this year or recently, some folks were using a technique called astroseismology to study stars. The star that was the candidate's host was one of the stars that was being studied. And it turns out that if you use sort of these star quakes, the star sort of jiggles and the waves bounce around on the inside of the star, giving bright patches and dim patches. And if you take spectroscopic data, you can actually watch all of this happening on these star surfaces. You have to do a model, and it tells you how big the star is. So between the Kepler data and the seismology, they were able to determine that that star was not only 10% bigger than the sun, it was 3 times the size of the sun, which then that planet, that exoplanet going around it, isn't Neptune-sized, it's suddenly a little bigger than Jupiter. Something a little bigger than Jupiter as it orbits its star. When it's next to it, you're getting a little bit of light from it. And when it's almost lined up exactly, you're seeing that whole face lit up. You get a little bit of extra light, it goes behind the star, that light disappears. It all suddenly makes sense. So now, this planet, instead of being small, is bigger, and it has been confirmed. So the very first Kepler candidate is now a confirmed exoplanet, and we'll have to up our exoplanet count in the depths of space, make it 1 higher. So I just thought it was kind of neat that the very first candidate it had took this long to confirm, even after it's found thousands of other exoplanets around other stars.